Okay, welcome back. And so far we have covered the calculation for radiators, for baseboard radiators, and radiant floor heating. And so these are two ways that we need to have some kind of calculation to know what kind of appliance or that should be put in the room in terms of hot water system components. The second step is after we decide where we're gonna put, whether radiant floor heating or baseboard, where are we going to put the boiler? So it can't be put randomly. It's good to know what is the best location based on some codes. So make sure it has been approved by the building owner. That's one tip. Check the local codes and national codes for uh, what are the minimum requirement, because otherwise, if you design the system, if you place the boiler and it was not approved and you have to relocate it, that's going to be a big headache. So for oil installation, use NFPA 31 as your primary code and look for the updated one. National Fire Protection Agency. For gas, it's NFPA 54. You can always Google these things and find them to know what is the minimum code for these boilers. And again, we're saying boiler because we're dealing with hot water system. Electrical installation, we can also have electrical heaters for hot water system as well. And there's an FPA 70 for that. Checking the venting system and combustion air requirement, that's a very vital way. And please do not forget about that. And just keep it in mind. I'm sure if you start doing some installs, you will have some kind of code given by your employer. But it's good to know that it's something to think about before you decide where you're going to put your boiler. Ensure that there is enough air coming into the boiler room. If you are going to install the boiler close to the outside wall, maybe you should do a sealed venting system instead of trying to depend on air coming from the basement. Make sure that the boiler is installed in a laundry room. If it's installed it's not installed in a laundry room or workshop, because again, it will need some uh, air to come in, and there's a possibility of carbon monoxide being leaked into a place where you don't want it to be. And if you are going to have the place as a living space, if you want to convert a a basement into a living space, or what's called finished basement, make sure that you have enough air coming in, and maybe you're better off having some kind of sealed venting. And maybe it's also good to have some kind of barrier between where the people are sitting or staying and the boiler. Some code require the boiler be installed and isolated by the local code. If the boiler is venting to a masonry chimney, make sure the chimney is in accord with the National Fuel Gas Code. And we did go over some chimney installation requirement on the NORA book in combustion control circuit. So more codes. So there are one. This is more code given actually by the IBR and ASHRAE. Think about combustible material, wood or carpeting. That's you do not put a boiler on wood or carpeting. You have to have a platform for that. Solid level foundation is a must. Consider the entire system and number of zones to reduce the piping requirement. Again, that's something that has to do with the planning. Most of the design is done on paper, but it's good to think about where you're going to put things, and it might save you a lot of hassle when you are trying to lay down the pipe. Make allowances for electrical work, and probably it's good to think about that when you're doing the wiring or maintenance. Do not put the boiler very close to other appliances. That will make things a little bit difficult for you to go in and do some maintenance when required. 15%, that's something we did for when we calculated the heat loss. And look for acceptable annual fuel unit. Look for appliances with good savings and good energy cost. Check the venting, and if it's a gravity system or if you have a power venters. And again, as I keep saying, check the local code. Every town is different and they have different requirements than other ones. Okay, uh, let's move on. So step 3 in the component. Once we know the baseboard radiator we need. We know if we're going to use radiant floor heating or baseboard. What What is next? The piping layout. Okay, we decide we're going to put the boiler in the middle of the house, or we find a location. Let's do the piping. What are the piping available and why? And what are the options and how do we recognize good or bad piping? So there is first thing the series loop. The series loop is very simple and economical, but you have a lot of high pressure loss and temperature will be lost in the first zone. Let me demonstrate. So this is the one pipe series system. So the water is coming out of the boiler. This is the hot water coming. It will go into the kitchen here. This is going to be high pressure and high temperature, right? So the kitchen will get all the heat, but then the heat will be lost from here, and you'll go to the dining, then the family room, the bathroom, bedroom. By the time you go to bedroom 3, you will have almost no pressure, and the water is almost cold. So this is not a very good installation. It's very suitable. It is suitable for a small studio or one bedroom apartment or something like that. But it's not good for if you have for this example. It's not a good idea to have this. This is kind of like connecting loads or light bulbs in series. Remember that? So the first light will get all the voltage and the current will be the same. So this is the whole thing. The flow is going to be the same because the flow is dictated by the pump over here, but you'll lose pressure as we go along. This one will get almost no pressure and you will lose heat as well. So this room again will get less heat as well. So that's the one pipe series loop. So less fittings, high pressure drop, larger circulator. These are the characteristics, and it cannot be used with indirect water heater for the domestic water system. Uh, Advantages: simple installation, very economical when it comes to installation, but no zoning, no high pressure. It has high pressure drop and high temperature drop, and it tends to overheat one area than the other. So this is a series split loop system. So it's still in series, but we have two zones. That's a little bit better. So if you notice here, the water is coming out, is going to one loop, and it comes back into this manifold, and another loop goes from here and goes to another manifold over here. Again, we added more piping. Again, piping does cost money, so we would like to economize, but this is a little bit better than having one zone in series. It's simple. Again, it's cheaper than having two pipe system, which we'll talk about soon, and it can be zoned. We have two zones only. It has better performance than single loop. Again, we still have issues with overheating, temperature drop, and also thermostat location is going to be an issue. Going back here, probably you can zone this area and this area using two different thermostat and a zoning valve as well. So you can put zoning valve in here or zoning valve in here, but it has to be only two zones and no more than that. Okay, this is one pipe diverted tees. This is a different configuration. It's still one pipe, but each one of them have its own tee. It has a lot of high pressure drop because diverted tees has a lot of it absorbs a lot of pressure. So we have one pipe system again, and the water goes to each one of them. But we have a diverted tee here that reduce the the intake of hot water into each radiator. How does it work? So the pressure is in here is going to be the same, these points, but each one of these radiator will have a control over the water that comes out of it. So a little bit, it's not going to take all the water, it will take some of it, and you can control which one of these have, using these valves, gets priorities. So it's again, still cheaper than having two pipe system, but and you have some kind of control over which one gets how much heat. Uh, but again, you have a lot of pressure drop, and you need to have large size pump. Again, it's a good option. It's not that bad, and this is how the diverted tee works. So we have high pressure here coming from the the main pump. We control how much water comes out of it because you know what comes in has to come out. So if you reduce the amount that comes out of it, it's going to take only little pressure from here, and then it will go whatever water will join in with the incoming incoming water inside. So high pressure drop when located in the upstream, you do not want to put diverter in the upstream, you want to put it in the downstream to make it like not absorb a lot of pressure, but we still have some kind of pressure drop. Um, and again, it can be put in the bottom on the top as well. So the two pipe system, which is the best, most elegant way to distribute heat through more than one room. And again, in this case, we still do have divertibles for prioritizing, not diverty, but we have a valve to dictate how much water goes to each pipe. And that's a really good way to put it. And we have one hot pipe and one manifold for cold water. So this is a two pipe system where you have the water goes uh, to each load equally. So this is kind of similar to connecting loads in parallel than in series. So I'll give you a second to look at it, see the difference. So one hot pipe supplying hot water to each radiator, then it pours back into the main cold pipe. It's better performance, lower pressure drop, balanced system. I consider it the best way to distribute heat in a big space. However, it's more expensive because you are going to spend more money on the piping, and it requires more involved installation. We've seen all the fittings and all the pipe going back and forth and so on. Uh, moving on, moving on. So flow rate, how do we calculate the flow rate and GPM? And I will touch base on that a little bit before we before we go into part two of this week. Again, there's a lot of small little calculations here and there, but they are not that bad. So this equation you will find in page 159 and under circulator and the circulator and pumps. How do you calculate the GPM? So whenever you go to the warehouse and you want to buy a circulator or a pump, they will ask you for two things: the head and flow rate. The flow rate is flow rate or FR or GPM, gallon per minute. Flow rate is volume over time. Okay, so the best way to calculate that is the heat load required by the room or the zone or the entire circuit divided by the temperature difference, temperature drop in that water over 500. 500 is a conversion rate. Okay, let's look at that example. Delta T is the temperature difference between the water entering the loop and the water coming back into the loop, and it depends on the water velocity, pipe type, room temperature. As general rule, you use 20 degrees. So this is the water coming into the radiator and coming out of the radiator. So the water coming into the radiator is going to be 180 and should come back at 160. It will drop 20 degrees in that loop. It's not the room temperature. Do not mistake that by the room temperature. The number 500 is conversion of the water weight per gallon and minutes to hours. So it's going to be constant. Okay. So this just to give you a taste of what's going to happen next week. We'll calculate the GPM, the flow rate required to go through the radiators and pipes based on the flow rate and the head. So that's the calculation of the flow rate, which is the GPM, and step 4 was selecting the piping for the entire house based on the GPM, which is the flow rate, and we will move on to calculating the pump that's required for that circuit. So for now, what I want you to think of is I'm gonna make it this is big a little bit. So what you have to think about is heat load per room. Then this will go into radiator size. That's going to be length, right? If you're going to be using baseboard radiator, length of baseboard. Or area required if you want to use floor heating. So you can look at the bathroom and see how much of a radiation rate do I need for that bathroom, or radiation rate for a bathroom or kitchen if you're going to use radiant floor heating. And that's so far what we did. And the layout, piping layout. So you can do this. Oh, before that, boiler location. So you are going to do these three things on your project. So I'm assuming you already finished the heat load for each room. So this is done. So you can go ahead and add the radiator sides for each one of them if you have baseboard. And if you want to do the kitchen and bathroom as radiant floor heating, you can calculate that, or you see how much radiation you need for the kitchen or the bathroom. Then you will uh, put in the floor plan where you want to put the boiler and why. Just think about it a little bit. It's good to print out the floor plan and go with a pencil and see how are you going to lay the pipes and how much radiation do you need, and just put it with a pencil and see if that makes sense to you or not. The issue that I want to think about that why, because some rooms requires a lot of heat supply, and if you're gonna go and run like 20 feet of these, it's not going to be a good design. You don't want to be in a living room where all around is just baseboard radiators. That doesn't seem like a very good, probable design. So what are you gonna do? You might want to have a convector, right? Which is kind of a cabinet that will push air through a radiator. It's kind of like the car radiator. So you might want to have one of those, or you might want to use a double row baseboard. Again, it depends how much you're willing to pay for that appliance or that piece of equipment. Okay, and so try to do that and do the piping layout so far, and we'll decide on the piping for the house on next week and the pump size. All right, thank you very much, and I'll see you next week.